We're moving on to adding and subtracting rational algebraic expressions, and I want to start with these simple fractions. When we start out with the textbook with some of the ones that are, algebraic in nature, we're going to look at things like, at first, x minus 3 over x plus 4, and be asked to combine that with, for example, x minus 2 over x plus 4. In this case, I already have a common denominator, so this is really, straightforward and not difficult. So this would simplify to x plus 4, and then I have a numerator of 2 x's, right? I've got an x here plus another x, and then I have a negative 3 plus a negative 2, which would make minus 5. So this simplifies to 2x minus 5 over x plus 4. And whenever we're subtracting or adding and we have a common factor, it's pretty straightforward. I will look at an example with subtraction just because there's a mistake that students can make because of the distributive property. Let's just look at 3x minus 4 over x squared plus 1. And from that, I'm going to subtract 6x plus 1 over x squared plus 1. So same basic setup here. We still have a common denominator, right? There's the common divisor. They're both over x squared plus 1. So that's going to be the divisor of my difference, right? X squared plus 1. But when I simplify this, it is 3x and then minus 6x's. So 3x minus 6x is a negative 3x. Where the mistake is made then is this is negative 4 minus a positive 1. So it's often a good idea to just throw parentheses around this and just remind yourself that you're subtracting this entire quantity. So it's negative 4 minus the positive 1, right? Negative 4 minus 1 is minus 5. So the answer here, whoops, I forgot the x there. That was a minus 3x. The answer here is 3x minus 5 over x squared plus 1. Okay, so that's the one tricky thing, right? Is that making sure that you recognize in a subtraction problem we're subtracting this whole quantity, and this entire quantity needs to be subtracted, not just the first term. Now let's move on to, fractions with unlike denominators, because this is where, it gets a little bit more challenging, not significantly, but some. So our book talks about finding least common multiples for each pair of expressions, and they had you practice that as a separate skill. I like to go ahead and teach it all in one step, right? Find the least common divisor and the new numerator simultaneously. And to do that, I really like looking at these in their factored forms for a couple reasons. One of them is that, well, it's easier for me to see what's going on with the individual numbers, and also because when we do this with polynomials, it's a lot easier to identify your common divisors and what you're having to do to get them, and how you're going to manipulate the numerators. Anyways, this is 3 times 7. Now, if I look at these fractions, right, I can see this first one has a factor of 2 and 7, and the other one has a factor of 3 and 7. Well, they both have they both have a 7 in them. But this one is missing a factor of 3. So I need to introduce that factor of 3, and to do that, I accomplish that by multiplying this first fraction by 3/3. Okay, my justification, of course, is 3/3 is equal to the number 1, and according to the multiplicative identity, I can multiply anything by 1 and not change its value. So I've just changed how this fraction looks. It is now a 9 in the numerator, and in my denominator, I have a 3 times a 2 times a 7. Now, the other fraction needs a factor of 2. I can see I've got one here, and I need to introduce that factor of 2 into the other one. So to accomplish that, I'm going to multiply this one, again, by the number 1. And when I multiply it by the number 1, again, I'm just changing its form, not its value. So to this, I'm adding 10 over 3 times 7 times 2. So my common denominator here is 3 times 2 times 7 or 3 times 7. It's those three factors, which equals 6 times 7, 42. So my common denominator is 42. And in my numerator, I've got 9 plus 10, which is 19. Because 19 is prime, I know that there's not going to be any common factors there. So this is my answer, right? This is equal to 1940 seconds. So I'm going to be modeling this as I work with polynomials. And if you want, come back to this example and see what I'm talking about. But for me, finding the least common multiple is kind of a silly separate step. So I'm going to be finding the least common multiple by factoring things and then building a common multiple, building the least common divisor. And at the same time I'm building that least common divisor, you can see I necessarily have to modify my enumerators. In this case, by multiplying the numerator by 3, and this one by multiplying it by 2.